Good afternoon. I'm Robert Croft from the Citrus County Historical Society. We welcome you today to our Save the Waters Week program. This is a hybrid presentation which we have people here in the audience as well as online. We are excited to bring Quinn Zacharias to Citrus County. Quinn is a 6-year student working on a combined master's and undergraduate program in engineering at the University of Florida. This is the 25th year anniversary of the Save the Waters Week. Mr. Zacharias is a Roy Lickens Scholar for the American Water Association and a research fellow for the University of Florida's Institute for Food and Agricultural Science. His presentation will discuss Florida's most pressing water-related issues, as well as providing cutting-edge ideas to address these issues. The funding for this program has been provided by the Inverness Cultural Heritage Council and Keep Citrus Beautiful. We welcome Mr. Zacharias.
All right. Can you see me? We're all fine to go? Very good. And so when I need to change slides, I press the... I'll click through it and we can... Okay. Left click, correct? Okay, great. All right. So that was a wonderful introduction. I really appreciate that. And today, we're going to be talking about Florida's most pressing water issues and maybe some sort of innovative ideas that we can do and look for in the upcoming future to address these problems. So I titled it 2020 Vision. I just thought it was a catchy name because here we are in 2020. There's been a lot of negative things happening, but maybe we can sort of find some positivity in our water resources at the state level. All right, so I did go over a little bit about my personal background. One thing I would like to talk about is sort of my research. I've worked on the Florida Everglades now for 2 years. I've been researching phosphorus management. Now, phosphorus is a nutrient. It's what you put in your fertilizers and things like that, and it flows into the water, and it can create issues with algal blooms and it can degrade the ecosystem. And so I wanted to sort of do a literature review on that in the Florida Everglades, which is a very unique ecosystem we have here in Florida. It's in South Florida, but in the process, I came across a lot of different studies and different pieces of knowledge about water resources, so I feel that I can address this to you today. In fact, let's talk about Florida's water reality. How much water are we getting flowing across our state? And on average, we have between 39 to 71 inches per year. In addition, Florida's population is currently about 21.5 million people. About 10 million is in about 10% of the land in South Florida, which you can see right there on the map. And about 90% of our drinking water comes from what we call the Floridan aquifer. It's the aquifer system that is underneath most of the state. So that is where we are today. Now let's talk about our water footprint. What are people doing as far as consuming water on a societal basis? Well, we can see that we've actually been reducing our amount of water that we use every year. I don't have up to 2020 2020, but you can sort of see the general trends in water consumption. Now, something that's very interesting that's happened within the past 10, 20 years is the agricultural amount of water consumption is now actually less than the amount of water consumption for municipalities. So that is, I believe, to be a product of better water management use on the in the agricultural section. So I did a little homework for this presentation today. I went back and I did what's called a literature review. Now, a literature review is where you go through academic literature published by scientists and researchers and government officials and engineers in journals. And so I wanted to see, what are the experts saying? Don't just take my word on it, but let's see what are the experts saying. So we can look here and we can see on the left, you'll see publications per year. And then on the right, on the x-axis, the bottom axis, you'll see the time. So we can see that at about 1990, we really started to see a lot of emphasis in Florida put on water resources. And it's a very strong topic that we're still talking about and probably will continue to talk about in the future. So now, what exactly are they saying? What are the biggest issues? What are the scientists saying? So I got two reviews, one from 2004 and 2018. So in 2004, these authors, they created a list of issues they thought were pertinent in and around Florida. Now, this is regional distribution issues, so getting water from one place to another, making sure people have drinking water, flooding, and we're also worried about drought and flood cycles, so making sure people aren't experiencing flooding in the streets and that we have enough water for our crops, and then contamination. So these are all very down and grounded issues, but it seems like in 2018 we started to see different issues coming up, and we started to see maybe a more interdisciplinary and maybe more meta approach. It's sort of what these scientists were thinking. So we talk about climate change and sea level rise, but something that is pretty interesting is they thought that water management needs a more interdisciplinary and collaborative approach. And as someone that has worked researching in the Florida Everglades, I can tell you that is more important now than ever, because in a watershed, the area where water collects and drains into rivers and streams, you have a lot of people, you have stakeholders, you've got municipalities, you've got farmers, you've got all kinds of different people. And so we need to come together in order to sort of solve our watershed issues. So that's something that they brought up, which I think is a very great point. So now, I'm going to take you through 5 key issues that I think we need to be looking at around the state. And so the first one is stormwater, flooding, and erosion. So stormwater, that is you can maybe have an idea of what it is, just kind of looking at it, but there's really more to it than that. Stormwater is essentially the product of changing our landscapes. So over the past 100 years around Florida, we've been cutting down trees and forests and putting up parking lots. Well, when rain precipitates onto the ground, we see that it's very good at reducing the speed at which that water hits and either evaporates or soaks into the ground. But when you just have a giant parking lot, that water hits the ground and shoots off into canals at a very fast rate. This increases the amount of water in a shorter period of time that flows through our waterways, and that can create problems with flooding. So we call this stormwater flooding. And there's problems with erosion because now you have water moving at a much faster pace. It's a lot of energy. That changes the erosion that we have on through these creeks, and it can cause a lot of problems. So what you see up here is you see You see flooding on the far left, and on the middle and right panels, you see a flood surge, and then you sort of see the erosion as a result of that. And that's a big problem around the state that we're sort of looking at how to address, and there's been some different ideas. Maybe we can talk about that later. Nutrient management. Now, this is something that I know very closely. I talked about it earlier. So nutrients is, it's what plants and animals use to grow. However, what we've done in the state of Florida is we've dumped tons of nutrients onto our lawns, our gardens, things like that, and through our fertilizers, and it slips right into the waterways. And in addition, I think I'm going to talk about this more later. You'll see a lot of nutrients that pass through us into the septic systems can also carry a lot of those nutrients. But what we've done is we have what we call over-eutrophied our water. So when I say over-eutrify, what I mean by that is it's over-enriched. Eutrify, enrich. We've enriched our water with nutrients, completely changing the ecosystem within our waterways. And so here you see a fine, handsome fellow pushing a mower. I wonder if he knows a whole lot about fertilizers, but we'll move on. So groundwater and spring protection. So this is what I think to be the third biggest and most pressing issue. So springs, many people call them the gems of Florida, the hidden gems of Florida. They provide clear, crystal clear water and places for recreation and unique habitats for endangered animals like manatees. And so they're under threat because people have been soaking up water from the aquifer because remember, 90% of our water supply for consumer use is from groundwater. But what happens is when you overpump, the water pressure that would normally flow into these springs is no longer here. And so we need to sort of balance consumer use with trying to protect our spring flow. And in addition to our spring flow, there's a lot of sewage contamination because we have, as I said, septic tanks. So a septic tank is, it's the tank that we use for treating sewage, usually in more remote rural areas. However, it usually does a pretty good job, but sometimes there's too many in too close of an area, and it can create nutrient issues and bacteria issues and even pathogen issues. So you can have things like fecal E. coli or fecal coliform, which are different bacteria, which are indicative of other pathogens that can travel through groundwater. So we can literally contaminate our own groundwater if we're not careful. And then the other problem that I see our springs having is invasive species. We're seeing a lot of invasive species in our springs, blue tilapia, among others, hydrilla, and these completely change the ecosystem. So we need to sort of understand the problems so we can address them. But I'm optimistic, and I'm optimistic because there's things like the Florida Spring Alliance and different spring commissions and that are taking action to save our springs by putting ordinances on the amount of water you can pull out, protecting watersheds, removing invasive species. And so while I do see that there is a decline, I also see that there's also opportunity. So number 2, coastline protection. This is a big deal. Now, a lot of times, we think of the word sea level rise. And I think for many people, that's a very abstract idea. That, it's sort of out there, we don't really see it, we don't know if it's going to happen in 10 years, in 100 years, in 1,000 years, if at all. There's a lot of evidence that says that there could be an issue, there could be issues, but what I can tell you is that in Florida, protecting our coastlines is very important. We've built our cities along the ocean, but on barrier islands. And the thing about barrier islands is that naturally they shift, they move. When a hurricane comes through, it will bust up these islands and change them around. But we don't really like it when, the sandbars we've built our casinos and our hotels wash out, even though that's the natural course that Florida takes. So I think that it's very important to understand how can we build on our coastal cities in a way that is protective against hurricanes, flooding. In Miami specifically, we see a lot of problems with flooding. So that middle picture you see right there, that's flooding in it. And essentially, one of the issues that we see in Miami is that you have a huge multi-billion-dollar economic powerhouse, a center. We have a lot of people, and sea levels rising. So the evidence suggests. And as that happens, you can't just put up a seawall. And there's a reason for that. It's because if you put up a seawall, it's like putting up a seawall over a sponge. Florida's rock, its bedrock, is made out of karst topography. That is limestone. And limestone, it's very porous, and it would allow the water to seep up and under. So literally, if you put up a seawall, it would just come right out the other side. So what you need to do is you actually need to build a pump to push that water out the other side. But here's the thing. You have to build gigantic pumps to pump out huge amounts of water out of these urban areas. And you have to increasingly build larger pumps because the sea level is rising even higher. So you need more energy, more capacity to move this water. So there's solutions, but we gotta think. we gotta think pretty hard about this. And there's a lot of people doing it. So the conventional solution, seawall, isn't really panning out the way we thought. But here's a very interesting idea. Our natural coastlines are very good at protecting from things like erosion and flooding. Mangroves, oyster bars, seagrass beds, spartina. Spartina is just it's like a grass that grows in sand dunes. It's very good at protecting from waves and surges and things like that. So what they're trying to do is do what's called coastline restoration, where they kind of get rid of the seawall, put in these more natural features, and they're finding astounding results where they can protect our coastal resorts and houses and things like that. And so here is what I think to be my number one issue. Now this is subjective, and I'll open it up later to see if maybe you disagree with me, sort of in a Socratic manner. I'm no official source, but this is my educated opinion. I think harmful algal blooms is an issue. Now I know that here in Inverness, this is where we are, we're in the Inverness courthouse where Elvis was here some decades ago filming his movie, Follow That Dream. It's cool. I think it sounds like a really cool movie. Haven't seen it, but anyway, so here we deal with nutrient issues, not specifically algal blooms, but I think it's worthwhile to talk about while we're addressing this on a state level. So harmful algal blooms are a symptom of nutrient management. You put the nutrients in, and the harmful algal blooms will explode out of control. And when the algal blooms do that, they soak up a lot of the oxygen in the water. So you have things like fish kills, the seagrass dies, and you have a whole avalanche of ecosystem collapse that follows. And once that happens, they sort of go into a bust state. So harmful algal blooms kind of go boom and then bust. And when they die, they can release a toxin. These, what we call cyanobacteria, also known as blue-green algae, can release toxins into the water, which can become aerosolized, which means they can go into the air, and they can cause respiratory issues. So a lot of people around the Naples area, around the Port St. Lucie area, have reported having issues with respiratory illness as a result of harmful algal blooms. And in fact, in 2018, in the gubernatorial election, for our last gubernatorial election, in the debate, the most debated topic, the topic brought up the most was harmful algal blooms and how are we going to fix them. So I think that is a very important issue. And the thing is, there's no real solutions yet. And that's what makes this so difficult. One thing that I'm very interested in is there's something called the George Barley Prize. They call this the American Idol for scientists, where they are going to award $10 million to the most innovative idea to solve harmful algal blooms. There's a competition right now. There's 3 finalists, and I believe the final winner will be announced this fall, maybe next year. I'm not entirely sure, but it's very interesting that people are investing in trying to solve this issue, and I think we can do it. I think that if we figure out how to control nutrients on a landscape level, come up with innovative solutions, I think we can find our way out. But as I said, the end is not near. I think that it's not the end of the world. We're finding ideas, we're collaborating, we're working together. And so I think this is key when trying to protect our state, our water resources, our environment. And let's talk about it. So nutrient criteria. So essentially what this is sort of managing the amount of phosphorus, nitrogen, other nutrients in our waters. And we do this on a landscape scale. We create something called a Basin Management Action Plan, BMAP for short. So when we do this, what we do is we sort of create these things called total maximum daily loads. So what this is a TMDL. This is where we say, okay, there's this much amount of nutrients, phosphorus or nitrogen, that we allow as a society into the water from agriculture, from municipalities, from cattle farms. And we say that, and that is usually generated by state agencies like I believe the Florida Department of Environmental Protection is who does this. And we actually have one here for Citrus County, the Crystal River Kings Bay Basin Management Action Plan. And so we even have this here at a regional level, and that was what I got offline. And that's it, right there. And so you'll see that I believe just a corner of Inverness Incorporated is in this BMAP, but you'll see that things like Crystal River, Kings Bay, the Springs, a lot of Citrus County is involved in this sort of larger cooperation. And in fact, we have these all over the state. We have these in South Florida, we have these in North Florida, the Panhandle, Central Florida, throughout different watersheds. The next thing is man-made wetlands. Now this is something I personally am very interested in because I think it's very cool that we can build wetlands. So throughout most of Florida's history, most of Florida was a swamp. Most of Florida was, sawgrass prairie. It was bald cypress swamp. And so what we said we can't really live in these kinds of environments because there's mosquitoes and alligators, dengue fever, yellow fever. And so that's where the phrase drain the swamp comes from, because there was a lot of illness and negativity associated with swamps throughout the whole world, but we see this very much in Florida. And so there was a massive campaign in the 1880s, 1890s, early 20th century to drain swamps around Florida, particularly the Everglades. We're going to talk about that in a minute. In fact, they drained about half of it. But what we realized is that if we restore these Everglades, these wetlands, we can use them to clean our water. We can send water through them, and the plants, the microorganisms, the sediment getting trapped in the matrix can pull astounding amounts of nutrients out of the water. And this right here is called Sweetwater Park. Now this is actually connected, this is in Gainesville, Florida, and it's connected to a Gainesville sewage plant. And so as a final treatment, they run water through this. This is completely man-made. They run water through it, and to help purify the water before it gets spread back out into a local prairie called Payne's Prairie. And it also acts as a wildlife sanctuary, and it is a park with boardwalks. So it also offers a great opportunity for recreation, where people can go out, walk their dogs, go bird watching, and even some fishing. It's really, really quite interesting, and we see these kinds of man-made wetlands, also called stormwater areas, because they can also treat stormwater. We see them all over Florida. We see them in Gainesville, Orlando, DeLeon Springs, the Florida Everglades, and probably many others. Those are the ones that I'm just aware of. Let's see. There are actually entire companies that have been created over the past several decades where all they do is they create wetlands. For example, Wetland Solutions Incorporated. They were based out of Gainesville, sort of out of the University of Florida, which was where a lot of these ideas were created by one of my biggest inspirations, Dr. Howard T. Odom. It's a professor that's no longer with us, but I really admire his work. So that, I think, about covers it. But actually, hold on. Let me cover the different mechanisms that are used. So we have, as I said, microorganisms. But we also have 3 different kinds of vegetation that we sort of classify. We look at what's called submerged aquatic vegetation. So it's completely underwater the entire time. We have what's called floating aquatic vegetation. And we have what's called emergent aquatic vegetation. So a lot of times you'll see in water management professionals, they'll throw around these acronyms, SAV, FAV, EAV, but that's what they mean. And that's a lot of times what they're used for in water management. So another one that is actually a little more controversial, it's called deep well injection. So a lot of times we have water that's polluted and we don't know what to do with it. And so one idea is they dig a well very deep into the earth, 3,000 feet, into sort of like salty groundwater, so we couldn't use it anyways. And they inject this water deep in, and the idea is that it won't travel into other water aquifers that we use for our groundwater. People talk about it. It's an interesting idea. I think maybe it might be a good last case scenario. It is controversial because we don't know exactly how well it's going to work. So it at the very least is risky. So I just thought I would mention it just because I thought it was an interesting idea. Something else that I find is very interesting is river restoration. So when we were changing around Florida's landscape and waterscapes, what we did is we would take these long rivers that would generally wind through Florida's flat topography, terrain, landscape, and we would sort of make them straight because it was more convenient, because it's a lot more convenient to track the amount of water flowing through, a square conduit than it is this sort of, long winding water body with branches and all kinds of wetland vegetation in it. So what you see behind me is actually the Kissimmee River Restoration. So what they did is they had dug this giant channel, which you can see is now kind of I guess a grassy field. It's not really grassy, it's just kind of dirt. And so they dredged it so they could get steamboats up there. But what they realized is that those slow winds throughout the river were actually very important on an ecosystem-wide basis. They would slow down the amount of water so we wouldn't have flooding. They would allow time for the plants to uptake nutrients. So what they did is they decided to go back and launch a very expensive restoration in the millions of dollars, I don't know exactly, where they would fill in that old river, and they rechanneled one that zigs and zags in a more natural fashion. And they've completed at least portions of it. I'm not entirely sure how much they've created. But that's something that is a big topic, is sort of river restoration in this manner. Well, this one didn't exactly turn out the way I wanted to. You can't really see it, but I can talk about it. So the Florida Everglades is a profound ecosystem. It is considered, and this is where I do a lot of my work, it's considered a wetland of international significance. It's considered a World Heritage Site by the United Nations. It's home to dozens of endangered and endemic species to Florida, including the Florida alligator, not the Florida alligator, but like the Florida crocodile, the Florida panther, a lot of wading birds. And it's one of the largest wetlands, I would argue, in the world. However, we haven't exactly treated it very well. And this is where we're going to talk about sort of how something went bad, but how we got innovative and we're turning lemons into lemonade. And so the Florida Everglades, we drained about half of it for housing developments and sugarcane and winter vegetables to grow them. It made a lot of people pretty rich, to be honest. Turning this, at the time, back in the 1880s, the campaign was led by someone called Mr. Hamilton. I think it's Hamilton Distant, something like that. And he led sort of a campaign to dry out the Everglades to make way for homes and things like that. And then there was a book that came out called The River of Grass that really sort of turned the paradigm on public opinion on the Florida Everglades. And we decided that it was worth keeping, restoring that. And then we also had a lot of issues with flooding throughout South Florida because the water would normally just seep through the swamps and the bogs and the forests and the prairies in a very slow manner. But now we channeled it all into giant reservoirs, canals, and when we got a big hurricane, the levees would break, and large towns, there were literally towns, I'm thinking of Belgrade, Florida, that were wiped off the map with thousands of people that died. And so that's where you had the creation of the South Florida Water Management District to sort of keep things under control. But what we realized is that we want to protect this. So in 2000, something absolutely remarkable happened. It's called the Comprehensive Everglades Restoration Plan. And I believe that's okay, so let's talk a little bit about the Florida Everglades. So on the far, it would be your left. That's what the Florida Everglades used to look like. It used to have water that would come down through the Kissimmee Valley, which is just south of Orlando, and then it would flow into Lake Okeechobee, Florida's largest water body, and then it would slowly filter its way through the Florida Everglades down into the Florida Bay and then the Gulf of Mexico. But this is what it looked like afterwards. Kind of looks more like a Rubik's Cube than it does a river of grass, if you ask me. And so this is what it looked like at about the late 1990s. And so in 2000, we decided that we were going to restore some level of flow to the natural Everglades to drain, not to drain, but to reflood the swamp. So that sort of gives you an overview of what we have. And then another thing, a lot of times we hear these harmful algal blooms. We hear it in the news, statewide, around the country. Where does that come from? Here's where it comes from. Lake Okeechobee. Lake Okeechobee has sort of been the reservoir that has collected all kinds of nutrients from cattle ranching, sugarcane farming, septic runoff, landscape runoff, and it's sort of just sat, accumulating in Lake Okeechobee. And so the thing is we got to find somewhere to put all of this nutrients, and we can't put it in the Everglades. The Everglades is protected by state, federal law. You can't do that. You have to clean it before you send it in there. So what do? They send it through. They created 2 canals. I believe it's I can't remember the exact names off the top of my head, but they send it out to the Naples area and the Port St. Lucie area. One canal is called the St. Lucie River, and the other one is starts with a W. What was it? Caloosahatchee. Thank you. I was having a little bit of a brain fart, but yeah. And so when that nutrient-laden water makes its way to the Gulf of Mexico and the Atlantic Ocean, it spawns these harmful algal blooms that we just talked about. And so we have to sort of figure out some ways. How do we treat this water? We'll talk about that in a little bit. Sort of my idea for graduate school, actually. So the restoration. So it was in 2000. It was conceived, over several, probably the 1980s and 1990s. Is a lot of the critical thinking on it was done, but it was signed. It was penned into law by the President of the United States in the year 2000. I believe it was. Can't remember exactly who it was, but at the time it was $8 billion, but they had to up it to $16 billion US, with a timeline now of 65 years. So we'll be seeing the completion in 2065. So it's a pretty long haul, but it is the largest, most expensive, most comprehensive environmental restoration the world has ever seen, and right here in our backyard. It's really something else. And so let me just tell you real fast about sort of one idea that I have for treating nutrients that only a few people are talking about. And this is shifting our agricultural practices, or at least incorporating them. And that is rice production. Rice, yeah, like rice and beans, rice, beans, and chicken, things like that. If you can grow rice, you can flood fields with plants in it, and when you remove the rice husk, what we eat, you actually remove a lot of phosphorus and nitrogen out of the water. It sort of acts as, a fancy term we use in environmental engineering is a bioreactor. It sort of works as a bioreactor to remove nutrients out of the water. So you can both create economic yield as well as provide environmental services for one of the trickiest environmental problems we have today. So let's do a little recap. Oh, by the way, that is something that I hope to study for grad school in upcoming years. So let's do a quick recap. 5 biggest issues: stormwater flooding and erosion, nutrient management, groundwater and spring protection, coastline protection, harmful algal blooms. Those are my sources. And yeah, that concludes my presentation on Florida's most pressing water issues, where I see things going, where I believe we can have some opportunities to incorporate innovative solutions, work together to protect our Florida waters at both the state level and hopefully here Inverness, Citrus County level as well. It's good to think at multiple scales at these kinds of things, because water doesn't know the lines we draw in the sand of our city or our county or our state. Water flows downhill, and that is everywhere around the earth. So it's something where we really need a lot of collaboration. And that is it. Any questions?
Well done. The Lake Okeechobee,
Mm-hmm.
and how it goes out to around Naples and on the other coast, is that what was causing that red tide?
Absolutely. So, red tide is something that really affects a lot of people. It shuts down beaches, and it kills a lot of fish, and can actually make some fish toxic. So you have a lot of industry in these areas where you've got fishing guides and a lot of outdoor recreation that is demolished by these issues.
So is that what they're working on, is filtering the water from Lake Okeechobee so that all those nutrients don't just go out directly into the other water?
It's very complicated. It's one of the most complicated systems. We're trying to fix a Rubik's Cube, I think, by pulling it together and putting it back together. We're trying to solve the puzzle.
But at least you're working on it.
Yeah, exactly. And it's because we recognize the value of the our water resources and our environment, and how important that is to keep our water supply safe, keep our wildlife protected, and our outdoor recreational areas clean and safe to use. Now, so sort of a little more detail on that. You have stormwater treatment areas. You have one on each. They plan to have one on each side of Lake Okeechobee, one on the Caloosahatchee side and one on the Port St. Lucie side, to sort of clean that water and then distribute. They're also building stormwater treatment areas south of Lake Okeechobee. So the idea is to send most of that water south into the Everglades to reflood. Yeah, so it's a very multifaceted project. So.
I like your idea of the rice, and and you wouldn't think about it, but in Arkansas, that's the largest agricultural product is rice. There's all kinds of rice paddies in southern Arkansas. Did I say Oklahoma? I mean Arkansas. So in southern Arkansas, there's all kinds of rice paddies there.
Yeah.
That's the corporate headquarters for Riceland Rice.
And one thing I think they're not fully thinking about is using those rice paddies as a way to filter out nutrients from the Mississippi, right? So the Mississippi has huge nutrient problems. Its floodplain is humongous. A lot of the heartland of America drains into the Mississippi, and so in the Gulf of Mexico we have these horrible nutrient issues, algal blooms, and what we call hypoxic dead zones, oxygen, which means there's no oxygen in the water, so the fish die. And they could be using these rice paddies to filter in, this water that already has fertilizers in it. And I think that's something that we need to think more carefully about, and how we can sort of kill two birds with one stone, so to say.
Sure.
So, they also do that down in Louisiana a lot as well.
The rice paddies.
Yeah, right there.
It's unusual to see them, like in a state like Arkansas. Rice paddies, but sure enough, they're there.
They're there. All right, any more questions, or we'll wrap it up? All right, thank you. Appreciate it.